Let's talk about wrapping all this stuff up. So we're going to be having problems with conditions like where they give us a condition, sine theta is equal to something, find the reference angle and find all angle thetas that fit the conditions. So the instructions will look something like this. Find the reference angle, all angles between 0 and 360 that fit the given condition. So if you're just looking like something like this, it says, oh, look, sine of sine theta is equal to 0.3.45. So this is just going to be inverse sine 0.345. So you're going to say, all right, if I do inverse sine 0.345, that gives me 20.182. Well, it's positive. You took the inverse of a positive, so you know your answer is the reference angle. So you automatically know you have the reference angle right there. Nothing to it. Then you look at it and you can say, okay, sine is positive. There's no other condition. Well, sine is positive in the first and second quadrant. So we have to go through the routine of, okay, when sine is positive, first quadrant, well, that's easy. That's reference. And then second quadrant, that's when we need to do the subtract from 180. So 159.818. Okay. We did inverse. How about this? First of all, cosine's positive, sine is negative. Cosine's positive, sine is negative. That only happens in the fourth quadrant. But it still wants to know the reference angle. And I kind of need the reference angle to find the fourth quadrant angle anyway. So same thing. You're going to say inverse cosine 0.234. So inverse cosine 0.234. So that gives us 76.467 degrees, but we got to turn that into the fourth quadrant angle. So 283.533. Okay. So I'm just, instead of saying 360 minus this, that's already on my, or okay, I'll do it different from now on. So if I looked at this problem, tangent equals negative, cosine's positive. That only happens in the fourth quadrant again. Now here's the problem here. Tangent equals to a negative. So if I do inverse tan negative 2.123, I get a negative 64. Well, negative 64 is not between 0 and 360, so it's not my proper angle, and negative 64 is not a good reference angle. Then somebody yells at me and says, yeah, but it's just the negative of the reference, so you know the reference is going to be 64. I agree with that, but it doesn't work out as obvious for cosecant and secant, or at least for secant and cotan. So what I always say is pretend it's positive for one step. Pretend it's positive for one step and do inverse tan of positive 2.123. And yes, I know you're going to get 64.778. And that becomes your reference. So see, you're always automatically finding the reference as your first step. Just pretend it's positive for one step, and that makes your reference angle. And this is, by the way, look, this works on these kind of problems where you have to find the reference angle. Then you use the reference angle. To find the missing angle. So now we need the fourth quadrant angle. So we'd end up with that. Kind of like over here, I've got cosecant. First of all, I'm going to say, I'm going to say, no, it's actually sine theta is equal to 1 over 1.234, because there's no cosecant button on my calculator. So my theta is going to be inverse sine of 1 over 1.234. And if you want to put the negative on there, you can put the negative. So you flipped it over because it was cosecant, and then you said inverse sine 1 divided by negative 1.234, and that made negative 54, which you know that's the negative reference angle. So the reference angle is actually positive 54. And then to find, oh, I forgot to do this. Cosecant's negative, secant's also negative. That's third quadrant. So the third quadrant is when we add 180 to our reference. Okay. Now this is where it gets a little funkier, because when you say, okay, secant is negative, and that's the only information. So when is secant negative? So second and third. So this is going to have two answers. So, secant is negative. So I'm going to change it. It's secant. So I'm going to change it to a cosine. So my work is actually going to be inverse cosine 1 over negative 2.876, like that. But if I do that, inverse cosine 1 divided by negative, 1 divided by negative 2.876. So I get 110. Well, 110 does make the second quadrant angle, but I think that might confuse some people, because some people are going to think that automatically makes the reference. So like I said, I would just pretend for just a second that it's positive. Do inverse cosine 1 divided by 2.876. Make it positive for just a second, just to find the reference angle. So when you do the positive, you get the reference. And I know some of y'all are going to say, yeah, but when you did it the first time, we got the 110. When you did it the first time, we got the 110. That's the second quadrant angle. And I agree with that. And you can use that to find the reference angle. I agree. And then you can use that to find the, okay, something doesn't look right. 876. Okay, that makes 180. That's close enough. All right, something just didn't look right. Anyway, so for the third quadrant, we still have to say 180 plus 69.653. So our second quadrant, or our third quadrant, becomes 249.653. Anyway, my recommendation is you just got to pretend it's positive, especially when you get to the cotan, because remember, you're actually going to have to do inverse tan. You're actually going to have to do inverse tan, which is going to give you a negative, which of course would be the reference angle. I don't know. There's all sorts of ways to think about this, but I like to just say, since I need to find the reference angle, just make it positive to find the reference angle. Let me see. Cotan's negative, cosecant's positive. So that's second quadrant. So when I do this, inverse tan 3.210. So that makes my reference 72.697. So the second quadrant is going to be 180 minus my answer. So 107.303. So anyway, this is what you need to know to get through worksheets 3 and 4, the calculator worksheets. Now, some of the worksheets have some extra restrictions that we can talk about in class, but this is the main thing. And we will just go from there and see what kind of issues we have when we start working them.